Hello everyone, in this video we're going to learn about implementing a stack using an array. In my previous videos I implemented a stack using a linked list, another kind of like a data structure, which we used like the methods available in the linked list. For example, we use the pushback and popback methods in order to implement a stack. So just to review this stack is a kind of like this structure, which is the last in, first out. In other words, it is a LIFO or LIFO. Kind of this structure means the last thing that we're going to insert on top of this stack will be the very first thing that we're going to pop from a stack. So I'm going to draw a stack here. So usually that's how we're showing a stack. It is closed from one side and is open from the other side, and the side that is open, that's where we're inserting a new item and we're popping the item. So again, as obvious, we can push any item on top of the stack, and that's going to be the very first thing that will be popped. So last in, first out. There are many examples of the stacks. Pile of plates, for example. When you go to buffet, and you can see that usually we are picking an item or a plate from the top of the stack. Not usually we are picking an item from the very bottom of the plates. Otherwise, we need to pay a lot of money for the damages that we make. So, going back to stack, and this time we're going to implement it using the array. So, we know that in general arrays are fixed in size. So, which means that we only have a limited number of cells or places to insert items. When we're implementing a stack using a linked list, usually we are not limited with the memory. We're not too much worried about it, although we can also set a limit for how many items we're going to insert on the top of the stack using a linked list. But the arrays are, as I said, usually are fixed in size, so we need to be careful when we're actually pushing an item on top of this stack. So let's see that how we can implement. And again, like many my other videos, I'm using a code very similar to the like the Java language. So here is the class stack, and this time our storage is actually an array. So again, it can be a generic type, so type T or E, whatever you want to like to call it. So that's, and then let's call it, for example, the storage. And then we can have another instance variable or another like a property of this class stack called size, which means that how many items do we have on top of the stack. So using an array, so this is the push method. Again, we're going to have like the data or the data of the type T, and again, we're not too much worried about the privacy of like these data here. If they're private or protected or public or another kind of like the scope. We're just, again, we're mainly concerned about like the implementation and not the very details of that. Okay, so the push method, and we're going to insert the data in on top of the stack. So first of all, we need to make sure that we have enough space or the stack is not full. We can implement the full method and empty methods just to do that. Or if you don't want to implement those methods, we can just simply check if the size of the link stack is equal to the capacity of the like the stack or not, which if you're using a language such as Java, for example, you can use storage length, which is the size of the size of the array. So storage, the length. So if this is the case, it means that we already have filled the stack with all the items that possible. So we just simply return maybe an error or show just error or raise an error. Okay. Otherwise, so in the else statement, we just saying that, for example, storage add location size then it's going to be the data. And after that, we need to increase the size by 1, because that's going to go to the next place. So let's see how the push method works. At first, the size of the stack is 0 because the stack is empty. So here, for example, we have a stack, let's say arrays of size 5, for example, 0, 1, 2, 3, 4, and here we go. So we have 4. So what's going to happen here, because the length of the storage is 5 and size is not equal to 5, it's going to the else statement, and it's going to insert the data at location size, which is 0. So let's say our data is 5, so I'm going to call the push 5 method. So 5 will be inserted here, and then increase the size by 1. So it's going to go here. That's going to be the very next place to insert the item. So again, we call, for example, another push method, for example, push 10. So 10 will be inserted here, and then increase the size by 1. So that's going to be size going to be equal to 2. So as you see here, size equal to 2 means that there are 2 items. At the same time, size specifies where is the next place to insert the item that we have. So that's the implementation of the push method. So the next method that we're going to implement is the pop method. Again, we're going to return the data from the type T. So as you see here, in the example of the push, size actually points both to the length or the number of items on top of the stack at the same time to the next place or the next empty place. So when we're going to pop an item from the top of this stack, what we need to do, we need to actually return the item which is the size -1, because here is where the size points, but the last data is at position size -1. So we can simply, for example, define like a temporary variable, for example, and then say storage at location size -1 will be here, and then we need to decrease the size by 1, so size minus, and at the end we're returning like the data that we just put. So for example, if I call pop method, what's going to happen, as you see, size -1, which is size is equal to 2. 2 minus 1 is going to be 1, so it's going to return the data at location 10. So this will be popped, and then it's going to increase size by 1, so size will be 1. One thing about implementing this stack using an array is, as you see here, we are not actually deleting the item from the stack, but because we're playing with this index size here, we're playing with this index size, so it actually ignores or skips like the existence of like the item of the stack. So because the size now points to this place, okay, size 1 means that this is the next empty place on top of the stack, although we have an actual data there at index 1, but again, because size equal to 1, and we have already popped that item, it seems that the stack doesn't acknowledge existence of number 10. So we can easily, we don't need to actually delete that. But if again, if you want to be more careful, for example, we can just delete the item at that location. But with this code that we wrote, the number 10 is actually is not here. So one thing that I forgot also to write in the pop method, we need to make sure that the stack is not empty. So that is with the case if the size is not equal to 0. So if the size is equal to 0, then we simply return null or nothing, or maybe just raising an error. So here is again this very simple code or implementation of like the stack using the an array. So going to the time complexity of the push and pop methods, as you see here, the number of operations that we do for both push and pop, no matter the size, is almost same. Or the constant number of operations. So both of them, push and pop, have the time complexity of big O of 1 using an array. So for sure, we can implement other methods such as the top method, which will return the item at the very top. Again, is going to be very easy to implement that one. You just simply return the storage at location size -1 without actually decreasing the size, because we're just returning without popping. Then also the implementation of is empty or is full, also very easy. You can just return if the size equal to 0 for is empty, or is full if the size of the stack is equal to the length of the array, or the capacity of the stack. So that's what we have for today for the implementation of a stack using the array. You can again watch my other videos about some other data structures, and also implementing the stack using a linked list.